Hey guys, today we're going to do the USACO 2017 January contest, problem 3, secret cow code. In this problem, we're given a string and an integer, and the cows are going to be building an infinitely long string. The way they're going to be doing that is they're going to duplicate the current string while putting the last letter to the front of the string. And they're going to do that infinitely. Our job is to find the nth character of the infinite string and print it out to the output file. To understand the problem a bit better, let's take a look at the sample input. So in the input, I'm given the n and the initial string. Let's just try to build the secret cow code from the initial string. So all we need to do is duplicate it and put the last character into the front. So we're going to keep the COW and we're going to put the last character to the front. So that will give us WCO. And we're going to append that to the current string that we have, giving us COW, WCO. Let's do that again. So we're going to keep the COW, WCO, but we're going to add another string, and that string is going to be putting the O to the front, giving us OCO, WWC. And we're going to get this string. So to do it again, here is the other string. One observation we can make here is that the length of the string is multiplied by 2 each time we try to make a new secret cow code. One way to do this is we can just create the strings ourselves until it includes the index n. However, n can go up to 10 to the 18, so that would not be very efficient. Maybe finding patterns will help us get to the answer more efficiently. So right now I see COWW repeating a lot of times in these strings. However, there isn't really a clear pattern, and the characters between the COWW don't really make sense. One observation that we can make is that we're duplicating most of the string every time we make another string. So let's take a look at the COWWCO string. We're duplicating most parts of COW. Specifically, we're duplicating the CO. So the CO is repeated and the W is out of position. So let's make that a bit more clear by doing this. Now let's move on to the next string. So in this string, the COWWC is duplicated and the O is out of place. So we can make it more clear by doing this. For this string, the C is out of place. So we can do this to make it look a bit more clear. Now that we've made spaces around the things that repeat each other, we can see that these strings are the same, and these strings are the same, and these strings are the same. So now every time it asks for an index, we can just move that index to the duplicated string before it. So if we were asked the index of this character, we can just, this character corresponds to this character over here. So we can just shift that index into here instead. This index shifting really saves us a lot of time because we are dividing the string basically by 2. And we can do it multiple times as well. After we've shifted it to this index, we can also find the corresponding index for the previous string. So we see that the index is going to be over here. So now this index also corresponds to this one because we're putting the last character to the front. So this will be the last character, and if we correspond it to here, we see it corresponds with this one, and this one is the same as the repeated string with this one, so the O is the same as this one. And we've moved an index from all the way over here to the second index of our string, which you know, it's O. This complexity is going to be sufficient because every time we're essentially dividing the index by about 2. So our time complexity will be log 2 of 10 to the 18. Although this all sounds a bit complicated, the code is actually very simple for this problem. So first, I'm going to read in the string and the n. Notice how I've set the n as a long because it can go up to 10 to the 18th. I also have this recursive function here, which I'm going to use later. So I'm going to subtract n by 1 because I'm going to be counting from 0 because that's how you do it in coding. So I'm just going to do it. And now we're going to get the length of the initial code. And then we're going to set our scope to the initial length first. Then we're going to change it. And we're going to say while the n is outside of our scope, which means that it is bigger, we have to increase the scope. So every time it's going to be increasing by 2. So we're going to do that. And now we're just going to run this recursive function, and we're going to put n and scope as the input. So the recursive function is going to take in the current index we're trying to get and the scope, which is the length of the current string we're looking at. That's all we need. So in the recursive function, we're going to split it into casework. So first is the case where the current is smaller than the length of our initial string. If that happens, we already know the character that we're trying to get, so we just return it. And then we're going to rescope the current scope. So if the current is smaller than the scope divided by 2, we're going to divide the scope by 2 as well. So that's a case where my index is pointing over here and the scope is still 24. We'd have to divide it to 12 because we really don't need this part. So we're going to keep doing that until the index comes after half of the scope. Now we're going to do another special case where the current is the scope divided by 2. So the current index we're trying to get is the scope divided by 2. So let's look at this one over here. The scope is currently 6. The 6 divided by 2 is 3. So the current index we're looking at is 3. So 0, 1, 2, 3. We're currently looking at this index. And this index is different because it is the last character of the string which we put at the front. So this index is actually going to correspond to this index right here. So the index before it. That's what we're going to do in the code. We're just going to return the recursive function of the index before it. And we can use the same scope because we know that we're just going to rescope it right over here. And then it's the normal case where the index we're trying to get is actually in the right half of the scope. So say we're trying to get an index like over here. This is a normal case because it's not in here, which is a special case here, and we're in the right scope. So we can correspond that right over here. And this index and the relationship between that index and this index is just going to be subtracted by half of the scope. So this length over here is 1/2 of 24, which is 12. We're just going to subtract it by half of the scope. So we're going to recursive the current minus half of scope minus 1. And again, we're just going to return the scope because we know we're going to rescope it. And that's it for the code. The recursive is going to do its thing, and eventually the current is going to be less than the length, which then it will return us the character that we want. Although this problem is more on the harder side, the observation that we can correspond the indexes and jump from one index to another made the code look very simple. Hope you guys enjoyed the video. Comment down below the next problem you want me to explain, and I'll see you in the next USACO problem.